I'm Andrew Smith, and this is my video lab report for Lab 7, which modeled the motion of a star. For the lab, we took data for the position of a star and analyzed it in VPython. We then used the results from this analysis to calculate the mass of a black hole. The given mass of the star was 1.989 times 10 to the 30th. The time step in between positions was given as 86,400 seconds, or 1 day. From the positions, we were able to calculate the velocity of the star. This was done by finding the change in position between 2 points and dividing by the change in time. In the lab, we were required to calculate the change in momentum, as well as Fnet, and the parallel and perpendicular components of both. The overall change in momentum was found to be equal to Fnet. This means that their parallel and perpendicular components will also be equal. The parallel component of the change in momentum was found using the formula delta P divided by delta T times P hat. Fnet parallel was equal to this value as well. The perpendicular components are found simply by subtracting the parallel components from either the total change in momentum or the total force, respectively. To help show the directions of the forces acting on the star, arrows were used to show their direction and magnitude. When running the code, it is seen that the magnitude of the forces starts out very small and increases as the star moves. This is because the momentum is changing more rapidly, so the magnitude of the forces are larger. To find the mass of the black hole, the formula for the gravitational force, F is equal to g m1 m2 over r squared, was used. Fnet was found from the computer model, as was the star's final position. Using the given position of the black hole, we can find the magnitude of r squared. This is then multiplied by Fnet and divided by both the mass of the star and g, the gravitational constant. This gives a final mass of the black hole to be 2.585 times 10 to the 31st. As stated earlier, the change in momentum is equal in value to Fnet, and so are their parallel and perpendicular components. However, they do differ in some regards. Although they have the same value, they represent vastly different quantities. Fnet is an experimentally determined value from the total number of forces acting on an object. Conversely, dp/dt is a value that is simply calculated from the given data. If you replace the given black hole with one in exactly the same position, affecting the star in exactly the same way with the same amount of force on it, you would not be able to tell a difference in the masses between the new one and the old one. This is simply because of how the formula for the gravitational force is written, and how you would calculate the mass using that equation.